Okay, in this video, we're going to look at reflections that go over the y-axis. So if you think about it, if I have a point that's over here, it's going to go reflect over the y-axis over this one. And so it's the x value that changes from positive to negative and vice versa. And so with mapping notation, what happens is the x value changes. Replacing, I know that u, and remember I always think of this as u and v, and this is my u. And so x or x value side is multiplied by -1. Invariant points are found on the y-axis. So if I have a graph here and I reflect it, this becomes here, that goes there, and this stays in that spot. And so if we consider what's going on here, let's look at an actual example of it here. So again, we take our function that is x minus 3, so it's moved to the right 3 and down 2. And if I'm going to reflect over the y-axis, this point here of 3, -2 will reflect over the y-axis to over here to -3, -2. This point here, 1, 0, will move over to -1, 0. But this point here will not reflect at all. It will remain here. And so if you take a look, that's what happens. So everything reflects across the y-axis. These ones go over to here and so on. So well, I know if I'm given the point -BC, well then the new point is going to be, this is saying that it's a reflection over the y-axis, so the x changes, and so the new point will be a positive BC. And so if I look at the next example here, here's my absolute value function again, and I've written out the critical points already. The critical points are kind of where it ends, and this is going to be the highest value in the range. This is the lowest value in the range. Hence, that's why they're critical points. And these are the y-intercept and the x-intercept. So if I take a look at these values here, and if I start to switch them around, if I reflect them over the y-axis, this is 10, 9. Well, that's going to turn into -10, 9. It's going to go over to here. -5, 0 will become a +5. +5. -2, 3 will become a 2, 3. -3 still. Cool. 0, -1, this value here will stay right there. It will stay at 0. That is the invariant point. And so now if I connect these dots carefully, and then I go this direction as well, I can see where my point is. And the point is going to be across 0 and down -1. This is the invariant point because the y value is 0. So if I multiply 0 times a negative, it doesn't change. Okay, let's try another example here. We're going to write the new equation after reflection in the y-axis. Well, if it's a reflection in the y-axis, think about yz. Reflection in the y-axis means the x changes. And remember, this is u and v. And so I'm going to do replacement here. I know u is equal to -x, and so x gets replaced with -u. Okay, so I'm going to replace x with -u, and y, or v, is just y. It stays the same. So if I replace this, f of x is just y. It stays the same. It's -2, and I'm going to put -u in here squared, plus 3 -u, and I'm going to change my u's to x's. So this is -2. U squared is just x squared, because that's an x, minus 3x. And so it's -2 x squared minus 3x. This is the new equation after it's been reflected in the y-axis. Similarly, if I do mapping notation for reflection in the x-axis, it means it's going to be x and negative y. Remember, this is u and v. And so u is equal to x, v is equal to negative y, and so y gets replaced with negative v. And so if I think about my function, here, I'm going to substitute this in for my y here. And so it's negative f of x, which is v or y or u, equals to negative 2x squared plus 3x. If I multiply both sides by negative, means f of x equals a positive 2x squared and a minus 3x. And there's how we can do some of our transformations.